Right. Let's take a look at another example. We're kind of work the opposite direction. So in this case, sodium has a density of 0.968 grams per centimeter cubed and a unit cell edge length of 429 picometer. What kind of unit cell does sodium have? Right. And so think about the things we know about the unit cell. If it's a simple unit cell, then you have 1 atom per cell. If it's BCC, we have 2 atoms per cell. And of course, if it's FCC, then we have that whopping 4 atoms per cell. And so if we find out the number of atoms per cell, we can then identify what kind of packing structure it has. So we know that we have 0.968 grams per centimeter cubed. And if we think about it, we can transform these grams into atoms. Right, that's something that we should be able to do using the molar mass and Avogadro's number. So we can go from grams to moles using the molar mass of sodium, 22.990 grams per mole. And then using Avogadro's number, 6.022 times 10 to the 23 atoms per mole, we can then get that there are 2.54 times 10 to the 22 atoms per cubic centimeter, right? So that's a whole lot of atoms, but that's in a cubic centimeter, which is much greater than a unit cell. So the next thing that we want to do is we want to transform this denominator from centimeters cubed into a unit cell. That way we can get into atoms per unit cell, see which one of these 3 it fits, and then that's the type of cell packing that it has. Obviously, you can do this in 1 line. I'll do it in 2 just to kind of show you. We, of course, know that volume is length cubed. And so if we have an edge length of 429 picometers, we can cube that to become 7.90 times 10 to the 7 picometers cubed. And that's the volume of 1 unit cell. Right, so we just created our conversion unit that'll let us go between picometers cubed and unit cell. So again, we have this 2.54 times 10 to the 22 atoms per 1 centimeter cubed. And we can see that we have picometers cubed. So if we can transform centimeters cubed into picometers cubed, we can then go from picometers cubed into unit cell, and then that'll give us the answer. So when we're going from centimeters cubed to meters cubed, there's 10 to the 6 centimeters cubed in 1 meter cubed. And you might be thinking, how did I know that? Well, you know that there's 100 centimeters in 1 meter. And so if you cube them, you cube both sides, not only do you have to cube the unit, but you have to cube the number. And so if you cube 100, you get 10 to the 6. Right, so 10 to the 6 centimeters cubed in 1 meter cubed. The centimeters cancel out. Now we're at meters. Now we can go from meters to picometers. So for every 1 meter cubed, we have to take our 10 to the 12th and cube that. You'll get 10 to the 36 picometers cubed. And now that we're at picometers, we can then now use our new conversion unit that we found, right? For every 7.90 times 10 to the 7 picometers cubed, you have 1 unit cell. Cancel out picometers, and then we're left with atoms per unit cell. Plug that all into your calculator, and you get 2. If you think about what kind of unit cell has 2 atoms per cell, that is a body-centered cubic, BCC. Again, these problems are very tricky. You can go about them in a number of different ways. The question can ask a number of different things. Really, the most useful thing is for you to actually do the exercise yourself, struggle with it, and then come up with a final answer. Of course, check the work along where you have the answer. You can check your answer, that kind of stuff. There's also many online resources if you wish. My main thing, again, is try to learn this actively. Don't just watch a video of how to find the answer, because you're not going to memorize the video because there's way too many different problem types that could be asked.